talking about that yesterday.
I do not do
I
it on
mean, it's a bunch
purpose.
of answers. I would
one quiz.
We're all the same letter.
Oh no, I would hate
Or
that.
that like there's one
The
of
first
each.
quiz was like all the
There's
same.
one of each I would love.
The first quiz was like A, B, B, A.
Because on the last quiz, I thought there was one of each, but that's because I put the answer.
That you didn't actually come up with, like your answer, the one you got wrong.
I wrote the answer, circled the wrong place.
I wrote the limited definition on my answer.
That's not even work.
I don't know. I was just looking at the last part of the problem.
That
Yeah.
should be minus 4.
There was a lot of similar ones. That's a tricky thing with multiple choice.
Well, I didn't even.
I was wondering the same thing, like the down strike here versus go through.
Okay.
You're thinking like, all right, they want to chicken nuggets. It's all good. And do cheeseburger. No idea that happens.
That's it.
Did I have the strawberry blueberry pumpkin?
Yeah, something like that.
Okay, inverse sine is 1 over 1 minus x squared. Chain rule, do you remember the times by half?
Yeah.
Okay, now you don't even need to do any simplifying because we just need to find it at the origin. So when x is 0, actually I can do this. So we just need to plug in 0. And this becomes a lot easier. Obviously, that's just 0. So you end up getting 1 times 1/2. 1/2 is the slope of our tangent line. We're trying to write an equation. And then the point is the origin. All right, so y minus y1 is 0 equals mx minus x1. So the slope is 1/2. Now, obviously, you look at your options here and you're like, none of these are in point slope form. So I just need to do a little bit of algebra. And you're like, I still don't see 1/2 x. So then, like I've been telling you, just recognizing which of your answers is the same. So in, I guess, technically standard form, when x and y are on the same side, we have no integers. So I'll just double everything. And then moving the y over, because technically standard form, we like the first x to always be positive. Which obviously that's the same thing as this. Okay, yes, A. Now this one, you didn't have to find the equation of the tangent line, you just had to find the slope of the line tangent to the arctangent of 4x at the point x equals 1/4. So, derivative for inverse tangent is 1 over 1 plus x squared. Oops. 4x here. Chain rule times 4. All right, so at 1/4. Obviously, 4 times a fourth, that's just going to give us 1. Put the 4 up here if you want to. 4 over 2, we get 2a. Okay. I told you, I literally, well, first of all, I took these problems from an AP exam, so I didn't decide which options were which. But when I'm making quizzes, I don't even think about it. I just steal the problems and.
Why did you plug in 1 instead of 1/4?
I did, but 1/4 times 4
Oh.
would give you 1.
Okay.
Yeah.
It's like that battery meme when he was like reading off the batteries. It was just like double A.
Okay, there's your little AP style warm up. Now, as I mentioned, we're going to go backwards. So still inverse trig functions, but now we're going to integrate. So the biggest thing in this lesson is like pattern recognition. So when you see something like this, now you might be thinking like, okay, we've done a lot with u sub. So you see something like this, you're like, I maybe would let u be my denominator, but look at your denominator is x squared. The derivative is 2x, and I don't see that located anywhere within my integral. Same like this, we typically, let u be our inside. But these are ones you just kind of have to recognize, okay? So you should know that the derivative of inverse tangent is 1 over 1 plus x squared. That's the same as that. So you just kind of have to pattern recognize if you see something in that form, and I'll kind of show you like an easy way to detect it. In that form, if I'm going the other way, if I'm given this 1 over 1 plus x squared, and I'm going backwards, I just have to recognize that that is the inverse tangent. Plus c, if there's some constant, obviously, because we're doing independent integrals. Similarly, and again, these are kind of like our main two, and we're actually only going to add one more in here, but we know the derivative of inverse secant is that 1 over the square root of 1 minus x squared, and then chain rule if needed. So if I'm given that derivative, that's in my integrand, and I'm asked to integrate, I need to recognize, hey, that's my antiderivative for inverse sine. So my best advice to you is these are. Ooh, did I record this one? Oh yeah.
I
Okay,
heard
good.
that.
Okay, thank you. Pattern recognition here. Pattern recognition is huge.
At least there was no joke this time, so we didn't have to re-record the joke. Oh Lord.
Maybe I'll come up with a good
Shit,
calculus.
what was it? It was like Amazon Prime.
It was like came in and it was like Amazon Double Prime.
Oh.
Maybe now you like get it more and it's funnier. I feel like before you guys were like, I don't get it. Oh, good old math jokes. Okay, so here are the ones. These are kind of like formulas, and this is, like I said, rarely tested on the AP exam. And because this quiz is take home, you'll have access to these formulas. But you really only need to know these two for sure. Number 3 would not be tested on the AP exam, but they don't even introduce you to secant and cotangent and cosecant. And the reason why is we know the derivatives of those are super similar to these. They just differ by like that -1 up top. So really we could manipulate any integrand by just like factoring that number out if it's a -1, and then we can use these 3 rules. Okay, so let's try an easy one. So here I see this integral and I have 3 over 1 plus t squared dt. And I was like, ooh, I know when I have something over 1 plus x squared, that's a little pattern recognition of probably inverse tangent. Okay, but I know the antiderivative for inverse tangent is 1 over x squared plus 1. So I'm like, okay, well, I have a 3 up here. Well, just like with any integrand, we can bring that constant out in front, and we could rewrite it like this. And then I see that 1 over 1 plus t squared. Again, not really a u sub I could do here. It's just a pattern you have to recognize that the antiderivative of that is arctangent. And then obviously you have plus c. So the antiderivative would be 3 inverse tan of t plus c would be that antiderivative. Okay, now unfortunately they're not all going to be that easy.
I even use T.
I do too. I actually really hate when they use the original variable as u, and then you have to do u sub. That really throws me off.
You do A sub.
You can do a sub, yeah.
B sub. Z sub.
Actually,
F sub.
we're gonna do something called a sub ish. Uh-oh, I'm missing a page here.
Oh, it says you gotta pause the notes and go on it.
Where did that go? Or I could just go for it, and if I do it wrong, we'll never know.
We will.
Okay, no, I feel confident I can do
And then
this.
you failed the AP test.
All because I showed you how to do 2 problems wrong.
Yeah.
She stated that probably would
He's just
be
like
on the
running that.
AP exam anyways.
So these you kind of use a little a and u sub, okay? So it's a little different than our classic u sub, but it's similar in the ways we manipulate with the u sub. So basically, here's like your 3 patterns you have to recognize, okay? Here's how you kind of differentiate these. If you see an integrand that has a radical in the denominator, it's either inverse sine or inverse secant, okay? Tangent's pretty easy to detect because that one's different. There's no radical, and you would see a constant plus the variable being squared, okay? So for example, like this one, I see a constant plus a variable being squared. that's a little trigger that might be a pattern of inverse tangent, okay? So then to tell the difference between these two, you look if there's like another x variable located outside the radical. Okay, so if I jump ahead to this one, you can see, oh, this one kind of looks like the pattern for inverse secant. I see the radical, I see an x squared minus a constant, so a is like a constant here. And I see another variable outside my radical. So that's kind of how you can differentiate between the three. Yes. Nice calculus pun too.
Funny.
So, no, not for this class. So as I said, like these are the only two you would have to maybe know for the AP exam are these two, and they're very rarely tested. And then I said, like in the one we actually didn't even learn this, so that makes me think that they really don't show up. Maybe like one multiple choice every so often.
Imagine we get
Right?
That's what you behind.
Okay, so looking at this one, I see a radical. So it's obviously either inverse sine or inverse secant pattern. Which one do you think it is? Sine. Why?
because I see the a squared and u.
I see the constant first, minus, and then u is always going to be the variable. And I don't see another variable outside my radical. Okay? So what we're going to do before I decide like what u and what a is I'm going to try to write these as something being squared. Okay, now this one's pretty easy because 4 is a perfect square. That's obviously 2 squared. And then obviously x is being squared here. So this is going to help you identify what your a is. So a is always your constant, and u should be a variable. If you want to write that down, you can. So a is 2 in this case, and u is x. A is 2 and u is x. Okay? And these ones, you'll be able to manipulate all of this in order to match like one of these patterns. The hardest part is just like recognize. Sometimes these patterns can kind of be in disguise. All right, so just like normal, when I do a u sub, I have to find du dx, because when I go to integrate it, it can only be in like terms of u. So if I were to just do this substitution right now, I'd have a squared minus u squared, but I'd still have this dx. Okay, so here's the part where it's similar to u sub. Normally, after we identify what u is, we find the derivative of that, du dx, which is just 1, which means du is just the same as dx. Okay, great. That's a really easy substitution, changing my variables there. So here's what we have. Since a is 2, I have a squared minus, since u is x, u squared, and du is the same as dx, so I can replace that with du. Okay, everybody good with that? So then that helps you match one of these integrals perfectly. I see, okay, I have my a squared, I have my minus u squared. So then I recognize this antiderivative is inverse sine, arc sine of u over a plus c. And then just like normal u sub, you just reback substitute in both u and both a. So this integral or this antiderivative is inverse sine of x over 2 and then obviously don't forget plus c. As always, you could check your answer by finding the derivative. Okay, that one's a pretty easy one to start off with. So I felt confident doing that without my notes. Trying to think if there's anything else I need to tell you about that. I don't think so. Basically, what you're going to do here is you're going to identify a u and an a and get it to match one of these 3 patterns. Okay, let's try another one. All right, looking at my setup here, which one of these 3 do we think it looks like? Inverse tangent, right? There's no radical. Inverse tangent. So let's try and manipulate this and rewrite it as something being squared. Now the 9x one, that's easy. That's 3x being squared. But you're like, 2 is not a perfect square. What squared would give me 2? Root 2. And that's okay. We can have a be the square root of 2. A is always your constant. And u in this case is going to be 3x. And then just picturing this, I'm going to have a squared plus u squared, so it's going to match this one. Okay, before I get too carried away, let's go ahead and do like our normal du dx is 3, which means du is the same as 3 dx. So just like before, we're going to factor out that constant for our u sub here. So that 1/3 is going to come out in front. I have a squared plus u squared. And then dx is being replaced with 1/3 du, which I already brought the 1/3 out, so du would be right here. Then I have a perfect match to there. Everybody good? Once you get a perfect match, and then obviously you can always have a number out here. We know that just carries down. Once you have a perfect match, you can find the antiderivative. So this is 1 over a. I'm just using that formula right here. Like I said, on the take-home quiz, obviously I have access to this. Arctangent of u over a, u over a plus c. There's my antiderivative. Back substitute in a is the square root of 2. U was 3x. Plus c. So the other thing I'd probably do here is just like multiply these together. Remember, you don't have to rationalize, so you can just leave it like this. Same thing with your argument for inverse tangent. You can leave that radical in the denominator. I know that makes some students uncomfortable, but let's hope that's the right answer. I don't know where my notes are. So. Okay, wasn't that fun? Should we stop there?
Yep.
Okay.
Fast.
Right? Time flies when you're having fun.
That was a faster period.
I'm curious for that paper I know.
It's magical and so on top.